In Scratch, we can also move sprites utilizing relative positioning. Relative positioning refers to moving a sprite based on the position it previously had. In our case, the cat is in the center of our screen. I can utilize the change x by 10 to move the cat to the right, or by -10 to move the cat to the left. I could also utilize the change y by 10 to move it up, and the change y by -10 to move it down. It is moving based on where it was previously. So if our cat started off in x0, y0, and I changed x by -10, the new x position is -10. If I click again, it'll subtract another 10 and be at -20 on the x-axis. Another way to do relative positioning is by utilizing the move blocks. The move block will move the cat forward based on the direction that it is currently facing. Right now, the cat is actually facing to the right. And you can tell this because in the direction area, if you click this, there will be an arrow showing which direction it is pointing. If you move this arrow around, you will see the cat pointing in other directions. If I keep this to the right and press move 10 steps, it will move in that direction. If I change this, then it'll move according to the direction that it is pointed. This doesn't require you to know the X or Y position of the object, but still move it around the stage. This directional arrow also includes 3 buttons here that allow you to have the sprite visually see the full rotation of its direction, or only see a left and right version of this direction, but still have that directional point actually work. Just because we don't necessarily see the cat pointing those directions doesn't mean it does not have the direction. It simply is only being represented with a left or right image. There's also the last tab here to not have any directional change of the sprite image, but this will still utilize the directional points. Another block that we can utilize is the point in direction block. This point in direction block utilizes the same circular degrees that we would see in the previous example. The numbers that are being utilized in this block, point in direction, actually point to very specific circular degrees. They work like this. Upward is 0 degrees. Going clockwise, the first is 45 degrees, 90 degrees, 135, 180, 225, 270, and 315, and then ending at 360 degrees. Now, Scratch also utilizes negative degrees. So you will see that there is also in other areas you can utilize -135, and that would be the same as 225. Or -90 is equivalent to 270. -45 is the same as 350, and 360 is the same direction as 0. Sometimes in code we may utilize one of these versus the other for some convenience, especially within the Pong game. Last but not least, there is also this turn degrees, which is turn clockwise a certain amount of degrees, or turn counterclockwise a certain amount of degrees. If I say turn clockwise 15 degrees, if I have my directional shown here, every time I click, it's going to increase the direction degrees amount clockwise or counterclockwise. We utilize this in our maze game to help point our mouse in the right direction. For your assignment, you're going to be utilizing this relative position. What we have here is a cat inside of a maze. When you start this over, you press the green flag. The cat will start at the beginning of the maze. And then we have this set up here so that when we press the space key, the cat is going to move. I've already provided the first few steps here. We will move 50 steps, turn clockwise 90 degrees, move 40 steps, turn counterclockwise 90 degrees, and then move 95 steps. When I press the space button, you will see the cat has moved 50, turned, moved 40, turned again, and has completed the maze to this point. The goal for you is to practice your relative movements by adding more turn and move blocks to this code of blocks in order to get the cat through the maze from the beginning to the end just by pressing the space key. If your cat lands on the black area, it will start over. Double-click that green flag to always reset. All of the turns are 90-degree turns, and you're going to continue just to add more and more of these and change the amount of move steps on each block until you've made it completely through the maze. You may have to experiment with different amount of steps and different blocks to get yourself where you need to be. Continue adding them until you have completed the entire maze. Once you are finished, make sure that you have shared the project and then copy the code link into the classroom. Thanks, guys.